everybody to our first lecture of the 155th season at Emory Grove. So we're so happy to see people here to hear Chad Shapiro. I will tell you just a little bit about how he happens to come here, but let me just remind you to pick up a brochure if you don't already have one. We have a lot going on. This is kind of the end of June for us, but in July we pick up. There's the 4th of July celebration that we have every year, and then on the 6th of July we start our hymn sings. Every Wednesday night we have a hymn sing at 7 o'clock here in the Tabernacle. Every Sunday night we have a worship service by a different church, so you can tell what they are by picking up a brochure or going to our website. We are having a speaker and a concert every month, June, July, and August, so check to see when the next ones are. All of our events are free and open to the public except our tea, and if everybody knows about our afternoon tea, it's back this year. So we've had a lot of people really interested in our tea, and it's the first Saturday of August. So again, check the brochure, check the website, you can get tickets online for that. So how did we get Chad Shapiro? I was watching with my coffee CBS Sunday Morning, and this interesting program came on, a presentation came on about light bulbs. And he said he had an Edison light bulb, and I'm like, wow, that's old. And then they said, and he keeps them in a storage unit in Owings Mills, Maryland. And I'm like, I know where that is. So I called him, or I emailed, I think, first. And he said he's gotten a lot of feedback on that, and I thought it was a fascinating presentation. So I said, can we talk you into coming here? And here he is. So I'm gonna stop and let him take over and show you what he has, and he has a wonderful presentation for you.
Hi everyone, thank you very much. I just want to say I grew up about a mile or two away from here. Went to Gilded Elementary, Franklin Middle, and I think it was called Franklin High, yeah? And I never knew this existed until, well, I knew it existed once Kathy contacted me, but I had never been here. And this is really a special place. As someone who appreciates history, this is a time capsule unlike anything I've ever seen. You go to Colonial Williamsburg and things like that, and it's all really new and replicated. This is really something special. So I just want to give you a little background about me. So I started my father started actually as a fan of a famous inventor known as Thomas Edison. And throughout his childhood, read books about Edison, studied what he could. And for his 21st birthday, my grandparents put an ad in the Sun paper looking for an Edison phonograph that they could give him for his birthday. And when he turned 21, they gave him this phonograph. When I was a kid, every year on Edison's birthday, February 11th, my father would take out the machine, crank it up, play a few records. And at first I thought it was kind of silly, didn't really understand what it was. And by about the age of 8, I caught on, and I was fascinated. And so we went and bought every book we could find on Edison. This was before the days of Amazon. And I read voraciously. And about 1997, I discovered a new website called eBay. It had been online about 6 months, and it was a different world on eBay back then. But of course, the first thing I typed in the search bar at the top was Edison. And not quite as many would pop up today, but all these amazing things popped up, including a light bulb, an Edison light bulb, which, by the way, can mean a lot of things. It could be something made in 1880, and it could be something made in 1930. And I called for my father, Dad, we have to have this light bulb. And he said, well, we don't know anything about light bulbs, so we're going to have to learn a little bit about that. So he remembered reading an article as a kid in the Sun paper, in the 1960s, of a gentleman by the name of Dr. Hicks, Dr. Hugh Hicks, who was an early light bulb collector, and he put together a collection or a small museum in the basement of his Mount Vernon brownstone, which is dentistry offices on the first floor. And we looked him up, and we went to go visit him, and that was it. I was a light bulb collector for life. That's the roots of why I'm here today. I will also tell you, sorry, I have to do this. When I was in high school, it wasn't easy being a light bulb collector. You're a little nerdy, you're not into sports, kind of puts you in an awkward position socially. And I remember many times having something go on that wound me up in the school counselor's office. And Mr. Kell was there for me. So he was amazing. He looked out for me as an awkward, weird, nerdy light bulb collector. So tonight we're going to talk about the dawn of electric lighting. We're going to tie this a little bit into the Gilded Age. Has anybody seen the HBO show, The Gilded Age? Outstanding, absolutely amazing. Maybe not so historically accurate in terms of electric lighting, but really, really well done. So what the Gilded Age is a period from about 1870 to 1900. And it's important to note that the Gilded Age is really what made the dawn of electric lighting, or this dawn of successful electric lighting, possible. It was at the peak of the Industrial Revolution, and there were people making a lot of money, or a few people making a lot of money. And it would take that money, people who understood and saw the future in technology, to invest their money and help create what we now have today as electricity. We take it for granted, but this is where it started. So, perfect. Batteries work. There we go, all right. So before electric lighting, we had, well, you've all used these before, right? So not really efficient, you constantly have to replace them, very easy to cause a fire, and, I'm sorry?
They make a mess.
They make a mess, but a lot of non-electric lighting makes a mess. So the next technology, if you want to call it technology, now what we think of today as technology, pretty simple, were various different oils. Here's an example of a whale oil lamp. This was something that had to be essentially farmed. You're killing whales to get it. And it was complex. You had to constantly refill this thing. It made a lot of bad smells. It just didn't really work very well. And then later we went on to kerosene lamps. We'll put out more light. You've all seen Gone with the Wind, that kind of that lamp.
We have them in our cottages.
Okay. There's not electricity in these cottages?
Oh, yeah, like it wasn't originally.
Okay, yeah, so the kerosene lamp, in many cases, lived in rural areas well into the turn of the century. So the first utility to deliver lighting of any sort was gas lighting. And gas lighting allowed an incoming service into the house. It just so happens to be that the very first gas utility was here in Baltimore, Maryland, the roots of BG&E. We all know them, we write them a check every month. But that is the roots of gas lighting. And gas lighting allowed a constant feed of energy into the house, which you could light. You could easily turn it on and off when not needed, and it didn't require a lot of maintenance. It did, however, create a lot of heat. In the summertime, it really made a hot summer even worse. And ultimately, it would cause soot to build up on ceilings, furnishings. It was really not very good. And in most cases, gas lighting, so gas lighting runs from about 1817 to, well, in Maryland, 1816, well into this turn of the century as well. Most people didn't have electricity when it first became available. So electric lighting. Electric lighting actually goes back to about 1800. So in 1802, you have to be careful with these dates. These dates, things change throughout history. They're not always recorded perfectly. But about 1802, Humphrey Davy took a group of cells, known as we call it today a battery, 2 carbon arc rods, or carbon rods, touched them together, and it basically made a short and caused a bright white light. And that was the first inspiration for electric lighting. About 1820, About 1820, De La Rue, between 1820 and 1840, again, the dates are somewhat sketchy, we find the first incandescent light. So the first incandescent light was basically a tube with, when I go this way, can you hear me?
Yeah.
Sorry.
All right.
Basically a tube with a coiled platinum wire in it. And when you take that platinum wire and you put it between the positive and negative of an electric current, it will glow. The problem is that would glow for a few seconds and then it would break. However, the roots of the what we would call modern light bulb, again, today they're not so modern, with LED, but the roots of the modern light bulb goes back to about 1820, before Edison was born. Uh-oh.
Go fix that thing. Do you want that?
You want somebody to,
Okay. Sorry. Let me just find a quick battery swap. I don't think that's it, it's the laser press.
Yeah.
kind of batteries.
I have, I'm sorry.
I have some in my pocket. While you're fiddling, our mom lived in Baltimore, and she says she can remember them coming by to light the gas lamp out on the street.
Yeah, yeah. My grandfather's job during World War II, when Baltimore still had gas street lighting, was to go around and turn off the gas lights during air raid drills. And he would ride up, put his bike against the post and climb onto the seat, shut the lamp off.
Another question.
Yes.
Did you say it was a platinum wire?
Correct.
Platinum.
Platinum. So platinum was a wire, or really is one of the metals that has the highest melting point, meaning the chances of it breaking are much less than a softer metal like copper. The problem is it's still, as we'll get to later, platinum never reached the ability to, might have worked later on because we used metal as filaments decades later, but at the time they couldn't make any form of metal work as a filament. This is really weird.
It's really
You know what, we might just have to, yeah. You want to read the clicker? I'll just give you a point. Oh, the space bar, yeah. So then in 1840 we have William Grove, and what William Grove did was form a vacuum. So anything that burns better in the presence of oxygen. So if you deny something that is incandescent, which burning until it emits light, oxygen, it should last longer. The problem was the vacuum that William Grove created wasn't strong enough. And now it's working. In 1860, Joseph Swan in England, his experiment led him to carbon. And carbon was the first material that was found that could incandesce. It was conductive, but it wasn't really a metal. It couldn't burn through and melt. So Joseph Swan started about 1860 by carbonizing materials such as paper, which if you put it into an oven and heat it to a high enough temperature, carbon will replace the paper. Just like burning a log, eventually what winds up on the bottom are carbonized remnants of that wood. And now it's not.
Every other.
Right.
Were most of these inventors from Britain or from America?
So far, nothing has happened in America.
Okay.
These are all European. Yep. And particularly in Britain. Yeah. So Joseph Swan's first carbon filament was made in 1860. And his first demonstration was 1878. We are still before Edison here. So if anybody did see the CBS segment, they made a big point of asking me if Edison invented the light bulb. And My answer was no, and we don't know who invented the light bulb. Was it Warren de la Rue in 1820? We're not sure. The roots of the concept go back to about the year 1800, but we really don't know the first person who made an electric light source. This is really frustrating. Wait, there's this little button that says connect. I wonder. Okay. And I'm also supposed to see this so I can see what the next slide says, but I can't from where I am. That's okay. So Swan lit his house, which was called Underhill in 1880. This was the first house ever lit with electric light. There was a local generator that would have been run by a steam engine, and that generated the power. We'll get to those generators a little bit later. And he outfitted his house for the first ever with electric light. And that house does still survive today in England. And in 1881, Swan founded the Swan United Electric Lighting Company. So this was the first electric lighting company in Europe, but it was not the first electric lighting company to exist. We'll get to that back. We'll get to that in a bit. So it's a shame I can't get this to work. So in America, nothing really had happened with electric lighting. There were a few experimenters that started with arc lighting. Arc lighting was a technology that used carbon arcs, like the very, very first electric lighting demonstrated by Humphrey Davy. But arc lighting was very, very, very bright. It was obnoxiously bright. It created this really, really bluish-white light that was fine for street lighting. It was fine for a warehouse or a factory. But it was so intense, it hissed. It was just not very pleasant to be around. It just wasn't something you could put inside, indoors. So, meanwhile in New Jersey, there's this guy, Thomas Edison. So Thomas Edison started his life off as a telegrapher. He eventually found that he was very adept at repairing telegraphy systems and started experimenting in developing telegraphy equipment. And no. Oh.
I think you moved, yeah.
Yeah, maybe you can. There we go.
Meanwhile in New Jersey.
Meanwhile, New Jersey.
There we go.
So in 1869, Edison was working for the Gold Stock Company, and when the system started to malfunction, Samuel Laws, the owner, brought in Edison to come repair it. Edison created an improved stock ticker for the Gold Stock Exchange, and was paid was paid around $100,000 in 1869 money for that invention. I'm sorry? It was a lot of money. He then invented the quadruplex telegraphy system. The original telegraphy system would allow one message to be sent over a wire. Very inefficient. So Edison wound up inventing an telegraphy system that would send up to 4 messages over one pair of wires. He sold that to Western Union in 1870 for $40,000. So, and look, we're working again.
We're teachers, we understand.
The ghost of Edison. So with that money, Edison purchased a building in Newark, New Jersey, and began inventing various concepts that never really took on, manufacturing telegraphy equipment, as well as other electrical apparatus of the era, and hired several very, very talented people. In 1876, he decided to set up an invention factory. So the concept of his invention factory is really the roots of what we would call the modern R&D facility. Nothing like this had existed prior. Menlo Park, New Jersey, which is not the same as Menlo Park, California. Menlo Park, California is in Silicon Valley. You would think that it's named after Menlo Park, New Jersey, the roots of the R&D facility. However, Menlo Park, California existed prior to Menlo Park, New Jersey. It was a failed housing project, and Edison was able to use his money he made through sales of equipment and investments, money he had made from the sale of his patents, to buy a plot of land, and he built several buildings, including the laboratory. Edison would hire local machinists, tinkers, he called them his muckers. Very few people at Menlo Park were college educated. There were a few, but the majority of the men that worked there had come there really with just some basic skills or advanced skills in machine work, many telegraphers, etc. It's interesting to note that many of these people, despite having no formal higher education, wound up being promoted later in life in large companies. Edison's head machinist, John Cruzy, who made the first record player ever, he became the first president of General Electric. John Cruzy was a Swiss machinist. He had nothing but an apprenticeship prior to becoming a master machinist, and became the first president of one of the largest companies to ever exist in the country. So the first successful invention out of Menlo Park was the electric pen. And what the electric pen was the first duplicating machine. I can tell this crowd probably, a mimeograph, right? You try to explain this to a younger crowd and they don't understand what a mimeograph is. Going back to elementary school, at Gilded Elementary School, I remember our teachers called it a ditto. And they called it the ditto machine. It was like this smelly purple ink. And I never saw the machine, but maybe you all can tell me if it was similar of a concept where you cranked a drum. And what the electric pen did was it punctured tiny little holes in a piece of wax paper, which you could write with it, and then put it into a press, roll ink over it, the ink would bleed through the holes, and you could make photocopies, not photocopies. You could make duplicates. And this was mildly successful. It didn't really make him a lot of money. And he was continuing to work with telegraphy. He was working on an experiment where you could record telegraphy. So someone sent a telegraph message in Morse code and a machine that could play it back. When that machine played it back, it made a bunch of kind of gibberish. And Edison thought that perhaps those markings, the dots and dashes created by the recording telegraph, could also record the human voice. And in 1877, Edison invented the phonograph. And this is the first prototype of the phonograph. And this was the first time ever that any person heard the recorded voice come back. And it was really an amazing thing. Edison took this to DC in the following weeks to demonstrate it for Scientific American. And when the first people that heard it, in many cases, they ran out of the room. They thought, they didn't, there was something wrong, maybe it was possessed. It really, really scared them. So with that, Edison gained recognition as the Wizard of Menlo Park. And with that recognition, he became the first really celebrity inventor in the country. Somebody that the public thought could do anything. He made a machine that talked. As simple as that is today, it's no different in operation as an LP that I say we all grew up with. I played with my kids. At the time, it was really, really something special. So Edison started off in his concept of electric lighting in 1878. And 1878 was a period, it was the start, some would say the peak, of the Gilded Age. And Edison knew that he would need a lot of money to find a working electric light. It was much more complicated than the working electric light. Joseph Swan in England, as we discussed, created an electric light. The problem was there was no system to deliver it. It was something that could be installed on a very small scale with extreme maintenance required. It could be used in a demonstration, but it wasn't really a viable product that you could sell, buy, use. Edison had the foresight to realize he would need to create an electrical grid. Nothing like this existed. The closest thing that existed was gas lighting. There was a central station where gas was pumped. There was piping going to different buildings. And that distribution model, Edison based his system on. However, he was basically starting with nothing. So he realized he would need money. And he found that money in one of the called robber barons of the Gilded Age, J.P. Morgan. It's interesting that they called them the robber barons. J.P. Morgan became very, very successful in the railroad industry. He became extremely wealthy, but he used his money to help further society. He was a philanthropist. The birth of venture capital. So really, this is the birth of venture capital, where a very, very wealthy person was investing their money based on faith alone that there would be a huge return. And I think he realized that he was helping change the world. He was also a cultural benefactor, so he built libraries, he built museums, he was incredibly generous with his money. So he may have been a robber baron, but he gave title or labeled as such, but he really did give a lot back. So once Edison had some financial backing, he went to visit William Wallace. William Wallace was an inventor in Connecticut, and William Wallace created the very first electric light ever sold in the United States. This is a fairly crude device here. This is actually an arc lamp. Between, right where that laser point is where the light would have emanated, and this would have been extremely high maintenance. You wouldn't have wanted this in your house. It was pretty bad. And ultimately it failed. Very, very few were sold. But Edison, there we go. Edison purchased one of William Wallace's dynamos. Now a dynamo is a generator. What a generator, an electrical generator. It is spun with a motive force. You'll see there's pulleys right there. Generally, the motive force was a steam engine, and it would convert that energy into electricity. And Edison purchased one of these machines. The original that he purchased still survives. You can see it today at the replicated machine shop at the Henry Ford Museum, the replicated Menlo Park machine shop. And he brought that back to New Jersey and began working on the electric light. Now, arc lighting existed in the United States as a utility just before Edison. So while William Wallace wasn't successful, Charles Brush was incredibly successful in electric lighting and would provide electric arc lighting was incredibly successful with electric arc lighting, which would be used into the turn of the century, mainly for street lights, not in Baltimore, warehouses, factories, etc. It could produce a lot of light from one location without having a very large infrastructure, but the light was not pleasant. There were retail stores who tried installing arc lighting within their stores. And the problem is they produce so much light, you couldn't put a lot of them in. So you'd put one in the center perhaps, and it would create all these terrible shadows amongst all the display cases of all the goods. The really harsh white light would make women's makeup, which they wore a lot at the time, look really, really obvious and chalky, and people just really did not like it. It was very unpleasant. So, back at Menlo Park, Edison founded the first electric light company, or the first incandescent electric light company in the country. In 1878, he founded the company with J.P. Morgan as his financier, and this is, it's kind of hard to read, but this is the first seal of the Edison Electric Lighting Company from 1878. So Edison's first experiments were with platinum, just like De La Rue. And other inventors had come in between, and platinum was what was used. And the concept of Edison's use of platinum was to stop it from burning. Once it got bright enough, it would remove the electricity, let it cool down, and return. So imagine the lights constantly pulsating on and off. It was pretty bad. It was not a usable electric light. So Edison ultimately went in the same path as Joseph Swan. We don't know if Edison knew what Joseph Swan was doing. Joseph Swan did not patent his incandescent lamp until 3 days prior to Edison's. So in 1878, it is unlikely that Edison knew what Joseph Swan was doing. So Edison's first successful filament was made of carbonized cotton thread. Edison had tried thousands of different materials. Ultimately, he found that carbonized thread was the thin nature of it would create a high resistance filament. And what was important for high resistance was it would put very little stress on the generating equipment. Joseph Swan's lamp, other experimenters at the time, were all low resistance filaments. So what Edison really understood from the beginning was the concept of subdivision of power. That was generating power in large quantities from one central location and distributing that to buildings within a reasonable distance. In order to do that, the electric lamps that he had made would need to put very little stress on that equipment in order for it to serve enough people. So this first successful filament was burned on October 22nd, 1879, and ran for 14.5 hours, or so they say. Ultimately, Edison's biggest success was found in a vacuum. So the combination of a high-resistance carbonized filament and a high vacuum, which would remove as much oxygen as possible, preventing the filament from burning through, would create this first successful lamp. And in 1880, January 27th, 1880, Edison was awarded his important patent for the invention of the light bulb. Side note, I was born on January 27th, but not 1880. I don't know if that's just luck or what, but I think there's some force that made this happen. What are the chances? 1 in 365, right? So from cotton thread, which really didn't last long enough to be a viable utility-based electric light, Edison found better success in carbonizing what they called Bristol board, kind of like the paper material of like a file folder. That was very delicate, also didn't last very long. And by early 1880, Edison had found that bamboo, carbonized bamboo, would be successful. Edison had searched the world for a vegetable fiber, as he referred to it. So the concept of carbonizing paper with very, very, very short grains of material would cause weak spots in the filament, where vegetable fibers, in this case bamboo, long grains of material overlapping one another made for a very, very robust filament. And Edison's bamboo filament was used until about 1892. So for over a decade, Edison used the same material, constantly improving how it was manufactured, but used the same material very, very successfully. And by November of 1881, the Edison light bulb takes on the base that we know today. You can screw this light bulb from about 1881 to 1882 into a modern day socket, and you can screw a modern light bulb into the socket made for that light bulb. So ultimately, Edison needed a system. He needed to develop everything. Nothing existed. He had to develop the generator. So what we see here is an example of the Edison dynamo. He had to develop the metering system. So what was the performance of the dynamo? Was it operating properly? Were we over powering the dynamo? All of that had to be created. Don't do it again. Did you press it or did I do it? No. He had to create the sockets. That is the first Edison lamp socket that will fit a modern day light bulb. Switches, and ultimately, he invented the fuse. Safety was a huge concern. People were very, very scared of this new technology. Despite gaslighting, burning down houses, and suffocating people fairly regularly, electricity was very, very much suspect. So Edison has his dynamo, he has his meters, he has his sockets, he has all of these items, and ultimately he needed a way to sell this to people. And Edison, in his Newark laboratory, met a gentleman, a master machinist by the name of Sigmund Bergman. When Edison moved to Menlo Park, Sigmund Bergman moved to New York City and started his own manufacturing firm, and he was the first manufacturer of Edison's first phonograph. Edward Johnson was the president of the Edison Electric Light Company. And that guy, Mr. Edison, they would all go into a company in thirds called Bergman and Company. And Bergman and Company would come out with their first catalog in 1883, and these were the first electric light fixtures. Again, none of this existed. He had to make all of this. He had to design it all. And Bergman manufactured the first electric lighting fixtures in the world. Prior to the Bergman lighting fixtures at Edison's Menlo Park laboratory, all of the fixtures were converted gas fixtures. So they would disconnect the gas, run wire along the fixture on the outside, and basically use the gas fixtures just as a means of holding the lamp socket. And we can see what some of those fixtures look like today. Oh, there's one right here. So, so these are the roots of what you might have in your house today as a light fixture. So the first installations. So the very first residential installation that Edison performed was a risky one. It was in J.P. Morgan's house. So the only test bed prior to this was at the Menlo Park Laboratory, which the complex consisted of an office, a machine shop, different employees' houses, boarding houses. Those were all electrified. So it was they were very good beta testers. Edison was actually the last to put it in his house. He let his employees try it first. And actually in 1879, when Edison gave his first public demonstration of his system, which was it was New Year's Eve, December 31st, 1879, there was a fire, which they quietly put out and kept from the public. So the Morgan house also has an interesting story. In Mr. Morgan's study, which you'll see a photo of right here, and you can see that lamp right there, I don't know how well you can see it, is that lamp right there, not the exact same one, and this lamp right here. Mr. Morgan's desk was in the middle of a rug, and at the time, there were no outlets to plug in an electric light. They hadn't really been developed yet. So Edward Johnson, the president of the Edison Electric Light Company, personally managed this installation. And he came up with this plan where he would have two metal spikes coming from below Mr. Morgan's desk, which would touch contacts that, as they pierce through the carpet, and transfer electric lighting to the lamp on his desk. The next morning, it caught on fire. Edward Johnson was called to Mr. Morgan's house immediately. He wrote in his memoir that he really didn't want to go. I don't blame him. He also wrote that after investigating the scene, Mr. Morgan showed up, and when Johnson went to open his mouth, Mrs. Morgan came up behind Pierpont Morgan and shook her head, and he remained silent. Ultimately, he fixed the issue, but the first installation didn't go so well. In Appleton, Wisconsin, a gentleman by the name of Henry Rogers owned a paper mill, and he was very successful, and he was building a house in Appleton that he would later call Hearthstone, and there it is. And Henry Rogers had the concept of building a central station that would feed both his house and his paper mill. This was the first central station assembled for electric lighting, and it just so happened to be that it was hydroelectric. It was driven by water, which is something that in decades later would become a major means of generating electricity. If you drive across the Conowingo Dam, not terribly far from here, you'll see it happening today. So this was the first hydroelectric central station in the world. Today, the house, Hearthstone, still exists. If you're ever in Appleton, Wisconsin, you should definitely go. It is the oldest surviving Edison installation. Many of the original fixtures are still in the house. They're powered by modern wiring for safety. But much of the house it looks exactly as it did in 1882 when Henry Rogers built it. The central station no longer exists, but a replica was built in 1933, and you can see the dynamo that is there in the replica behind it, an original drawing. Now this house was started, this central station was started in late September of 1882. And they had to wait. Edison required them to. Edison was working on his own central station, which was something he envisioned from the start. And it was what ultimately would make his electric lighting system viable as a marketable product. So Edison had to improve his generators. They went from small units, like the one in J.P. Morgan's house or his basement, run by a steam engine, much to the disappointment of his neighbors. And Edison developed much larger machines which could be used to light thousands of light bulbs in a central station. A machine of this size could light 1,200 light bulbs. At the time, they considered a standard size light bulb 16 candle power, the equivalent of lighting 16 candles. Today, we would know that as a 50-watt light bulb. And so combining about 10 of these in a facility, he could light 12,000 light bulbs. He bought a building on Pearl Street in New York, which he would convert into the central station. He dug up all of New York City and installed underground conductors, which you see here are two gentlemen who are working on the underground conductors. The underground conductors were made in 20-foot sections. They were iron tube with copper conductors inside filled with tar to insulate. You can see where they're splicing them and filling in with tar. Every 20 feet they needed a splice. And today this is a survivor, one of those splices, as you saw in the picture. This example was buried in 1890, a bit later, in San Francisco and discovered in 1879.
Those conductors are in the same tube?
Yes. So they were separated by rope, braided between them to hold them in place, and then pumped with tar. And this worked quite well. This was contrary to what caused fires in houses in the era. That was wood insulation. In so many cases, wiring was held in place with different wooden apparatus, which they later found would absorb moisture and become conductive and catch on fire.
Jack,
Yes.
had they decided at this point whether it was AC or DC current?
This is DC. We'll get to AC. We're going to get there. But AC, we don't go much into AC, but we'll get there. So we'll get there, because there's much to be said about that. So yes, this is direct current, which was Edison's fault in the long run. So on September 4th, 1882, Edison fired up the Pearl Street station. It lit a square mile of buildings in Manhattan and was the first operating central station in the country. There was a previous one that was launched in January of 1882 in England by Edison, which was a test bed for Pearl Street. And you can only wonder why he did it in England in 1882. News traveled slower back then, and if things didn't go so well, maybe he could buy some time. That's not history, that's conjecture. So Edison would start his plant on September 4th, 1882, at which point Hearthstone would not be allowed to start until after the Pearl Street station. Edison wasn't going to let somebody else steal his spotlight, someone he was licensing his product to. Very little survives from Pearl Street. It burned down in 1890. It was rebuilt, and by 1895 was shut down. This is a surviving document from, you'll notice it says 4 p.m. Monday, September 4th, 1882. And this is an indicator card. When a steam engine is run, An indicator card is generated by a piece of apparatus which will show you the capacity or the stress put on that steam engine by the load. In this case, the load was electric lighting generators. So this curve here is the capacity of the steam engine, and faintly drawn here is the actual stress put on the machine. And this is noted by Edison's chief engineer, who was there at the startup, that the small diagram faintly traced is the actual curve drawn by Mr. Edison. So this document was sitting next to Edison as the Pearl Street station was started. So ultimately, this was scary stuff. There were fires, but for the most part, the propaganda was from an industry that Edison was about to destroy, the gas industry. So the gas industry put out all kinds of propaganda pieces. This is from 1882 at the bottom, effect of the Edison Electric underground wires. And you can see the horse is walking along, and this guy is calling to this nice lady. And next thing you know, the wet ground causes the conductors to short, and everything, the horse is scared, everything's a mess. What's interesting about this piece from 1882 is that the drawing here depicts an arc light. They didn't even know what an Edison light bulb looked like. Slightly later, 1889, the Judge, which is these are both of the Judge, it was a political satire magazine. This, you can't really see it here, but it says death from the overhead wires. So this is an installation, this is 1889, where the wiring is strung overhead, and the electrician is being electrocuted, and another horse, and the policeman is running, and everything's going awry. This was the propaganda to scare people away from electric lighting. These pieces are, I find, very, very historically interesting. So Edison had to find a way that he could sell electricity. So the Pearl Street station is running, it's feeding several dozen structures, but he needs to then charge them for it. And going back to 1878, Edison understood this and started developing a meter that he could use to calculate the amount of electricity used so that he could then charge for it. The first 6 months of the Pearl Street station was provided for free. It was hard enough to get people to allow Edison to come into their homes, their businesses, and wire up the facility, and it was a trade-off that they would have the first 6 months for free. In 1883, Edison installed his first meters, and this meter was known as the chemical meter. It works by a process of electroplating. So electroplating is a means of transferring metal from one metal object to another. If you think of a pair of silver-plated candlesticks that are silver-plated, that process is done through electricity. This meter works in the same way. Inside these jars are 2 zinc plates, and as the electricity flows through, it transfers zinc from one plate to the other. At the end of the 30-day billing cycle, they would weigh the larger plate, and they had a formula to calculate how many lamp hours, how many hours a light bulb was burned during that billing cycle. It was so crude and often inaccurate, there are 2 jars, so they did it twice. If one was way off, you knew you had a problem, but otherwise they'd average the 2. This was generally installed outside. If this was in a cold environment, these electroplating jars did have liquid in them, and they could freeze. So there's a light bulb inside to keep it warm. The light bulb is on Edison's side, meaning he paid for that light bulb. This particular meter, let's see if we can get to the front of it again. Now I really screwed. This meter is a number 1, not that it's the first. This was rated for 6 light bulbs. So you take this, you adopt this new technology into your house. Maybe you put a few into your parlor. Maybe you put one on your front porch. Maybe you put one in the upper bedroom hall. It was adopted in very, very transitional steps. Most people who had electric lighting in their house still had gas lighting in the majority of the areas. In many cases, you would put it though in areas where you would entertain guests to show them that you have the means to adopt this new technology. So of course, once Edison had his patent, there were competitors. Edison had been working alongside other inventors to create the first successful electric light at the end of the 19th century. All of his other competitors were very, very, very far away. The issue with the patent system is once you file for a patent, it becomes public knowledge. You can then, it gives you the grounds to sue for patent infringement, but ultimately dozens of companies popped up manufacturing light bulbs based on Edison's patent. The first one, Edison's first competitor, was Hiram Maxim. And you can see here, he was quite the character. Hiram Maxim was of German descent, but born in England, and emigrated to America in the 1870s. And he was an inventor. And his work in electric lighting was not so successful, but there we go. In 1884, he moved to Germany and invented the machine gun.
Oh, gosh.
Edison used that against him. So immediately Edison began suing all of his competitors who were infringing, and ultimately in 1891 Edison won his lawsuit, and all of his competitors were shut down from manufacturing light bulbs based on Edison's patent, which was all of them. So all of these other competitors were basically selling a Me Too product, generally inferior, and didn't have anywhere near the market share. But there was one. 1885 in Pittsburgh. George Westinghouse decides to get into the electric lighting industry. And he hires an electrician. At the time, an electrician was an electrical engineer in many cases. Edison was labeled as a prominent electrician in the period. It wasn't what we think of today as an electrician. And Westinghouse hired William Stanley. And William Stanley had worked for various electric lighting companies prior, most notably Hiram Maxim. And he was studying the work of several different electrical firms in Europe who were using a power form, or an electrical power, that was discovered in 1832 called alternating current. And originally, alternating current was considered unuseful. It didn't work well for low voltage apparatus, telegraphy, etc. And creating DC generators was really a major challenge. So in many cases, AC actually comes before DC, to answer your question. So William Stanley modifies a transformer design that was created in England about 1883 by a pair of inventors named Gilded and Gibbs. Now what a transformer does is takes a very, very large amount of power, very high voltage, and reduces it to voltage that's safe. With AC, you can generate very, very high voltage, send it a long distance, and then at each building, reduce it down to voltage that is safe with a transformer. So with William Stanley's transformer, alternating current could be used successfully in installations. And ultimately, it would travel much further. Edison's system would travel at most a mile, and if you were at the furthest extent of the mile, your light bulbs were dimmer. It ultimately wasn't scalable, whereas alternating current was. You'll notice who we haven't talked about in regards to all this yet. In 1886, Edison and William Stanley installed the first alternating current long-distance electrical generating station in Great Barrington, Massachusetts. We still haven't brought up Nikola Tesla. Nikola Tesla, at this time, was still digging trenches for burying Edison's system wiring, interestingly enough. So Westinghouse at this point had a complete system, but there was one major thing that he was missing, and that was a motor. So what electric lighting and electrification did for industry was very, very big in manufacturing, because you could use electric motors to drive machinery. The same current coming in for electric lighting could also be used for industry for driving machinery through motors. Westinghouse didn't have a motor, and there were several people working on AC motors, but the first was a young inventor from Serbia by the name of Nikola Tesla. Nikola Tesla did not invent alternating current. What Nikola Tesla did do was invent the first AC motor, a patent that Westinghouse desperately needed. So with that, Westinghouse had a complete system. And this started what we now know today as the current war. There's a lot of misinformation out there on this period. It is often made to be an Edison versus Tesla battle, if you will. If you go on the internet, you will read all kinds of untrue things about this period. This was really a battle between Edison and Westinghouse. So, in the current war, Edison hired a gentleman by the name of Harold Brown. And Harold Brown had promised Edison that he could promote DC current in a way that would ensure his reign as the best system for electric lighting. Ultimately, Harold Brown would go around doing demonstrations where he would use alternating current, which he termed the executioner's current, killing animals, and various propaganda. You can think back to when Edison was being fought by the gas industry with propaganda, well, karma. And ultimately it didn't work. They did invent the electric chair, though, together. In fact, Edison coined the term, or supposedly coined the term, if someone was executed by electric chair, they would be Westinghoused. In 1893, Edison would lose the bid to light the World's Fair, and Westinghouse would win. The entire World's Fair was lit with alternating current generated by the system using Tesla's patents, Stanley's patents, etc. And in many cases, this was the first time attendees, for the period of a year that this ran, ever saw electric lighting. It was really, they called it the White City. Everything was bright, plaster and concrete, and it lit up beautifully. But Westinghouse had a major problem. Edison had just won his court case, and Westinghouse wasn't allowed to manufacture light bulbs. By this time, Edison's companies were now formed into General Electric, and when Westinghouse went to General Electric to purchase light bulbs, they said no. So Westinghouse had to design a light bulb that would work around Edison's patents. And he ultimately did so. I won't go into great detail about how it worked, but it was a pretty poor product, but it got him by. By 1894, Edison's patents expired, and business was back to as usual. In 1897, Westinghouse launched the Niagara Falls Power Station. This was the first major power station that could generate long-distance electricity for about 3.5 miles. The city of Buffalo was first lit, and this really was the start of the electrical grid as we know it today. Edison had moved on from electric lighting by about 1886. He had gotten wind that another inventor was toying around with an invention he had put aside, known as the phonograph. That other inventor was Alexander Graham Bell. Alexander Graham Bell had come up with devised the concept of recording into a wax surface. And Edison wasn't about to let his favorite invention, which he called his baby, go to the hands of another inventor, certainly not Alexander Graham Bell, and he further improved the phonograph, ultimately creating the first entertainment device that could play back the human voice or recorded sound in the country. And ultimately, the Westinghouse current won. So with that, we're going to close. That brings us up to what I would consider modern electrification. And anybody have any questions? Yes.
You started saying that the Europeans started the initiative to have electric light bulbs and everything, but then looks like you forgot everything about the Europeans. Did they not do anything after that?
No, they did. They did. I'm sorry that I could talk about this for many hours if we were to cover everything. So in Europe, right after, there was no real, the first system of electric lighting absolutely was developed by Edison. And Edison then began offering it for sale throughout Europe. There were other companies in Europe, most predominantly Siemens, which still exists today, which made major developments in Europe with electric lighting and improved upon Edison's system there. But in the period of around 1882 to about 1890, there were so many people involved. Invention doesn't happen with one person. So what was happening in Europe was very much based on Edison's design until European companies started using alternating current. And those early alternating current systems inspired William Stanley, who thus went to Westinghouse and convinced him to use alternating current. Westinghouse did not originally intend to use alternating current. Westinghouse's first systems were DC, and he was jumping on the bandwagon just to take advantage of a business opportunity. If it wasn't for the European development of the transformer by a company called, well, the first transformer was 1883 in England, and then by 1887, there was major AC installations by a company called Zibernowski in Budapest. So, anyone else? Yes, sir.
I wanted to mention for regard to the colleges that grow, my grandfather got an electrical engineering degree in about, I guess, 1825 or something like that, and he was involved with installing knob and tube electrical current in a lot of these cottages here. So if you look in your rafters, you'll see still the knob and tube in a lot of the cottages here. He also was involved in wiring breweries in Baltimore. So when the revenues came in and the alarm would go off and the brewers would run out, and so that's the way he made his money. But a lot of the cottages have knob and tube wiring still in the ceilings here.
Thank you. Do you know what year that was that he started? What time period?
In 1928, he was doing it in the late 20s and 30s, I think, here at the Grove.
What cottage has one in it? Do you remember? Your old one?
I used the Zeus cottage.
Mary's.
No, it's not active, but it's still up in the hill.
But do you know that the person I bought the cottage from was still using it, which everything about it scared me. So I had to redo the whole thing. But they're up there on the rafters just for show, but no use.
Yeah, so knob and tube, if untouched, is not unsafe. The porcelain, the tube is porcelain, the knob is porcelain. The tube is what allows the electric wire to go through a piece of timber, and the knob is what is used to attach the wire when running it alongside timber. That design comes to fruition about 1890. Prior to that, all of the different mounting methods were all wood-based, which was very problematic. So once they started using porcelain, the safety factor is pretty good. The problem with knob and tube wiring is if you start to modify it. So once you decide you're going to install a modern light fixture, you now have wiring in a box that has brittle insulation. You can't by code transfer from knob and tube to modern wiring. So ultimately in the long term, it makes sense to replace it. But as it sits, if it was all original components, it's actually pretty stable and safe. So.
I read a book about Nikola Tesla, and I was under the impression that he really had a bigger role in this than I guess that he really did. I don't know, but didn't he work with Edison first?
So Nikola Tesla was sent to the United States by Charles Batchelor, who was Edison's right-hand man, who had gone to Europe to start distributing or marketing the Edison system. He had a lot of faith in Tesla. He was a brilliant man, and he sent him to New York with an introduction letter to Edison. Tesla was then hired by Edison to work at the Edison Machine Works, which is where the generating equipment, the dynamos, were manufactured. Edison decided he was going to try and develop an arc lighting system to compete with other arc lighting systems, and he employed Tesla to do that. Ultimately, Edison scrapped the work and never used any of Tesla's patents. There's a story that exists that describes Tesla as having been told by Edison that if he had achieved a certain milestone, Edison would give him $50,000. What's interesting is when you read Tesla's description of that scenario, he described it as the manager. And the manager of the Edison Machine Works was John Cruzy, who was Edison's master machinist from Menlo Park, and then would go on to eventually be the first president of General Electric. So is there a chance that John Cruzy told Tesla that if he could achieve X, he would give him $50,000? Perhaps. The story that claims that Edison was cheated out of, or Tesla was cheated out of this at the hands of Edison, it's a nice story. The interesting thing about Tesla, and now you're opening a can of worms, by the way. It's a good can.
You don't have to.
There is a modern revisionist history attempt to glorify the underdog. All right. Tesla had a patent for an AC motor. Elihu Thomson, another major early electrician. Galileo Ferraris in Italy. Ferranti in Italy were all working on AC motors. It was Tesla who had the first successful one patented. Had he not existed, one of those other guys would have achieved it. It might have taken a few more years, but they were on the right track. He also invented multi-phase AC current, which allowed even further transmission. It was, again, something that was being developed based on an Edison design called the three-wire DC system at the same time, and two-phase was used for a very, very short period of time. Today we have single-phase, which is in most people's houses, and three-phase. So Tesla then became very much a socialite. He's described as sort of this shy, meek person who was taken advantage of. He actually enjoyed the limelight. He ate at Delmonico's in New York City almost every night, had his own reserved table there. There are articles describing his demonstrations where he was quite the showman. So Tesla is an intriguing fixture, but the concept that Tesla invented the modern world, it just isn't supported by history. I'm somewhat biased. I've been Edison guy most of my life, but the facts.
That's probably why I like it.
Yeah, and there's nothing wrong with that. But the other thing, this whole Edison versus Tesla thing is kind of ridiculous. Edison's phonograph factory burned down in 1914. There's a surviving letter from Tesla to Edison with condolences and encouragement for starting back his factory. There is a surviving, well, there's the copy. When Edison would send a letter, his secretary would write a copy, and then Edison signed that copy. In the Edison archives, at the Edison National Historic Site, there is a letter to Tesla from 1896 where Edison is asking how he's doing with his experiments and wishes him well. There was no war between Edison and Tesla. It was very much Edison versus Westinghouse. It's now made out to be Edison versus Tesla. And if you look on the internet, it's grown to ridiculous proportions. There's all this discussion that Tesla had developed a way to deliver free wireless energy, and the FBI infiltrated to stop it so that the capitalists couldn't make money. It's all silly.
Thank you.
So, sure. Anyone else?
You want to tell us what you have?
Oh, yeah. So, thank you. I brought a few things that you can come and look at. This is an original Bergman & Company lamp. So this is an original surviving lamp that was made by Edison for his system. It is not the one that was on J.P. Morgan's desk. Well, it could be, but it's unlikely. But it is the exact same model. In the middle is an Edison chemical meter. That is that first meter that was used for calculating the use of electrical power usage for electric lighting. And on the end is a very small but real Edison dynamo. That particular dynamo had the capacity to light 10 lights. So you actually could use it in a tabernacle like this. You wouldn't have had this much lighting, but back in the 1880s, 7 or 8 light bulbs would have been quite impressive. So feel free to look at it. You're welcome to touch it carefully or touch them. And
We didn't have as much lighting anyhow.
yeah.
All right. Thank you.